Thank you all so much for joining us for another one of these sessions. I'm Christina Yasini. I'm the product lead for Ecosystem Code, and today we'll be covering another exciting aspect of domain-driven development and its applicability that we're seeing in this space as we progress, honestly, and as developments come up over time. So the title of today's discussion is Replacing Enterprise Software Without the Enterprise Build. And this is mainly about moving from business description to a deployed system without the dependency on a vendor and having that lock-in that we tend to see throughout the industry at the moment, and that has been the case for the longest time. And the best part about the developments in AI is that they extend beyond just simple tasks and have revolutionized how we see business operations and the systems that govern organizations in their different spaces. And one aspect of this that we want to apply is in understanding how ecosystem code is that bridge in the capabilities that it offers from the onset throughout the functioning and the deployment of the system as a whole. I would like to just set the landscape for how we've come to understand this and how the space has evolved over time. And what tends to happen in a lot of companies that tend to have a lot of employees, I'm talking in the hundreds, is that they find themselves, particularly in 2026, at a point where they're having to make a decision on how they want their enterprise systems to function in a way that integrates AI capabilities, but also captures the true capabilities of how they've designed their systems to operate over the years. And that operation is what gives them their unique edge in terms of the services that they offer and the products that they offer and the way that their productivity and systems are distributed. So, for example, if we look at an enterprise resource planning system, which tends to be the software that manages the operational and financial backbone of a business through purchase orders, inventory, and a general ledger, you have companies that are dependent on providers such as SAP, right, which are one of the most widely used ERP platforms in the world for the past couple of years. And what comes with these is license fees that tend to reach the millions of dollars depending on the scale of the organization. And over a large number of years, you have internal teams that have built customizations on top of this platform that is provided from the vendor to handle the different parts of the organization. But the thing is that the provider, such as SAP, was never designed for that particular business. It just simply provided a generic system for everyone. And so reconfiguring and customizing it tends to be quite a difficulty, and even more so complex when you have years of legacy systems that have compounded to create and be the backbone of how that business functions. And so parts that were specific to how products were manufactured, how the supply relationships were managed, how you track down production is quite embedded into that vendor, right? So we're seeing a lot of leaders in organizations that are asking to look at alternatives. And there tends to be consulting firms that play this role where the firm can spend 3 months scoping a migration, coming back with a quote that's in the millions of dollars and a quote that also could take about 24 months just to complete. And that figure did not include any new custom development. It's just the migration of the existing data and logic onto a new platform. And this is not necessarily a solution because the monetary commitment is still quite large, as well as the time commitment, right? The business is not stopping its operations to oversee this. And so the new year comes around and you find the organization still locked into this contract with the vendor. And this is not an unusual case. It's quite common for procurement leads in many retail groups to describe almost the exact same position, and even HR directors in professional services that have been trying to exit, for example, human capital management systems, which are softwares that handles employees, payroll, and leave for years, and they cannot make the exit work in a way that balances out the numbers. And so the purpose of this session then is about the option that and this is not necessarily to position this as a new vendor or building a custom system from scratch, but something genuinely different. And by the end of the section, I hope we'll be able to understand what exactly that looks like and whether this can be applicable to organizations quite far and large. I will say before I jump into the agenda, if there are any questions throughout this, please drop them in the chat section, and I'm happy to answer them at the end of this as well. So firstly, we're just going to look at a quick sense of where we're heading. We're going to understand the problem, not to necessarily dwell on it too much, but to understand that framing matters for what comes next, right? We'll look at why the obvious options exist, why buying a platform or building from scratch tends to be the next best option, but to also understand the structural problems that most organizations face that are not necessarily accounted for. And then from there, we move on to the main section, which we will look at a different model, right? One that starts from your own domain, which simply means starting from how your business operates, how it's already designed. And when I say business, I don't want to limit this to organizations, but I just want to limit this to whatever capability and function you are seeking to create, right? To have a system that is built from that original intent and captures that throughout the process, no matter the scale, because once you have that foundation that is set, the scale, it's easier to expand that when the scaffold is structurally constructed in a way that can manage that demand later on. And then from there, we move on to what is known as the ecosystem code wizard, which is one of our latest product developments that is used to capture that intent in a plain language. And ontologies, which I will dive into a bit later. And we had a session on this last week. If you have missed it, fear not, it is available on our YouTube channel. And we've come to explain it quite in depth as the semantic map of how your system works. And from that map, that's how your system is then generated. And then from there, we will look at what it means to actually own what you build in practical terms, and then close off with an open discussion with a few questions that I have for our attendees today to help and understand them for what they are currently doing at the moment. Cool. So firstly, I think it's important to understand the problem that we are facing at the moment, right? There are three interlocking issues that most organizations that run enterprise software are dealing with, and they tend not to be discussed together, which is part of why the situation persists in the way that it does. And the first is that of license compounding, right? Where you have enterprise software licenses that are typically priced per user, per module, or both. And they tend to increase every year, maybe by 5%, maybe 8%. And so as you add modules, which can be understood as the specific add-ons for things like expense management, contract management, or field service tracking, this increases also the cost layers. And so by year 5, what you can have is you are paying considerably more than you were at the start, but the software is doing essentially the same things it always did. You just have gotten used to that functionality. And a concrete example of this is Salesforce, right? It's a customer relationship management platform that manages your sales pipeline, your customer records, and support cases. And it has a published list price. But once you add the Sales Cloud license, the Service Cloud license, the analytics add-ons, the integration licenses, and the support contract, it's not unusual for a company of 200 salespeople to be spending between $1.5 to $2 million per year for a system that they do not own. And then from there, we have the second issue, and that is that the domain that you work on lives in the vendor's schema. And so schema can be understood by how your data is structured and labeled inside a system. So when you use an enterprise software for long enough, your business and organization can adapt to their language, their processes. And so your workflows come into fitting into the way that the vendor is organized around your product. And that then connects us to the third issue. And this is one that actually keeps many people in bad contracts, right? The exit costs. Enterprise software vendors design their products to make switching honestly expensive. Integration plugins, data formats, or trained staff, all of this creates friction. And so what ends up happening is that the cost of leaving in most cases is higher than the cost of staying. And vendors know this, and this tends to be their business model. And so what this then leads us, or connects us to rather, is this idea of the false binary problem, where on one side, you buy a platform either through SAP, Oracle, Salesforce, or Workday. And these are serious battle-tested products that are used by some of the largest organizations in the world. And when you're buying them, you are not designing a system for your organization. You are simply configuring someone else's, right? And on the other hand, you have the option to build from scratch. Custom development, you own everything outright. There are no license fees after delivery. But the delivery itself is a risk, right? You have this custom enterprise system that can take 2 to 3 years and cost several millions of dollars. And once it is built, you need a team to maintain it. And that team needs the right expertise. And if those people leave, that also means that the institutional knowledge has the potential of going out the door with them as well. And so the reason this choice feels so bad is that both options have genuine structural problems. Buying gives you something that works, but you never truly own. And building gives you ownership, but the cost and risks to get there is prohibitive for most organizations. And so the golden pathway is one that can look slightly different and provide a different starting point. And so the question then becomes, what if the system started from how the organization actually functions, not from a vendor's product catalog, not from a development team that can build within a given budget, but from a description of your actual domain, how your departments operate, what your data actually means, who can do what, and what decisions get made. And let me try my best to make this as concrete as possible by looking at it from two parts, right? The traditional path is that you identify a vendor, you go through a selection process, you sign a contract, and then you start configuring. You spend months mapping your processes to the vendor's data structure. Some of it fits, some of it does not. And the parts that do not fit become workarounds, where after 3 years, those workarounds are load bearing. You cannot remove them without breaking something, right? And then you also have the domain first path. And what this looks like is that you describe how the organization operates. You describe the entities, which can be understood as the core objects within that organization, like the customers, the orders, the suppliers, or the employees. You describe the relationships, how those different orders connect to each other, and your rules, right? Who can see what, who can approve what triggers what. And that description becomes the model. And from that model, a full working system is generated. And so what this results in is that you are defining the problem. You're defining the problem and not the architecture. The result is a system that reflects your business, it runs on your own infrastructure, and the code that is then developed from that is what you own. There isn't any dependency as well. And our initial approach to providing this capability in a way that is as seamless as possible is through the ecosystem code wizard that captures that intent. And it starts with a couple of main questions, which are simply a guiding setup process that asks you these questions before any code is written, before any UML diagram is output as well. And these are not technical questions. And this is also particularly when we think about teams and organizations that use this in their daily processes, right? You have the objectives of the executive in the organization and how they want things to be done. And then you also have the lower level team members within departments that oversee the output of that. And so the aim is to provide a space for that capability to occur. And with the first question of what your role is, gives the platform context for what kind of output and recommendations will be most useful. And architects, for example, that is building a system design needs different things from the platform than a business owner that is validating whether a concept is viable before committing to resources. And the benefits of this is that it allows you to prototype a full system before having an extensive monetary commitment before you even get started. which then connects to the second question, right? What kind of system are you building? And here you choose an enterprise domain. We'll look at the full list on the next slide, but the categories include things like customer management, financial and operational backbones of organizations. You have people and payroll management, you have supply chain, warehouse management, and more. And this preloaded knowledge within the platform that is ecosystem code about the entities and relationships that are typical to your domain comes with each choice. And so you're not starting from a blank page. And our thought process, even working on this, was to emphasize having an intelligence layer that starts from the beginning and is carried out throughout the system, so that when you are working with the different parts, when you're working with the output, when you're applying certain changes, that intelligence still connects to the original foundational intent, but also understands the purpose of the whole system through its different components and can output that at the last stage. Which then also connects us to what is your first goal, right? Are you building something new? Are you migrating away from an existing system? Are you validating a design before committing to the budget? And that answer shapes what the platform then surfaces as a whole. And this we included in thinking of the more technical teams in organizations that want to set the technologies in which the systems will run on, right? So you, for example, could have React for the front end, and this is the part where the users see and interact with. Or you could have Node.js for the backend, which is the logic layer that handles the requests, the rules as well. Or you could have MongoDB for the database, and this is where the data is stored. These are the choices that are default for most use cases, but they are also fully adjustable. From there, we move on to the next question, which asks you who uses the system and at what scale. So a system that is built for 20 internal users looks very different from one that handles 2,000 concurrent users. And this affects how the generated system is architectured, right? This then connects also to how the epic and user stories are also set up, right? Where we think of an epic as a high-level goal. For example, the purpose of the system is to manage the full supplier onboarding process. And user stories, on the other hand, are the specific actions within that goal written from the perspective of the user. So, for example, if the high-level goal is to have a system that can manage the full supplier onboarding process, as a procurement manager, you want to be able to see all the pending supplier approvals so you can act on them before the deadline. And so this is then drafted into the system that is able to answer all your questions. The value of this is that you are able to review and adjust them before anything is generated. And so what comes out of this process is not simply a specification document that sits in someone's email, but a structured description of your domain that seeds everything else: the diagrams, the code, the authorization rules, and the documentation. And all of it flows from those 6 answers. I would spend a couple of minutes just providing an overview of what we mean by ontologies and the preloaded knowledge they provide for your system. And every category here is a type of enterprise software that organizations are likely paying licenses for, right? You have CRMs, which are customer relationship management systems that capture the customer records, sales pipelines, or support cases. And you also have ERP systems, which are enterprise resource planning systems that are provided by vendors such as SAP, Oracle, that also have a financial and operational purpose within many organizations. And then you also have human capital management systems that are provided by vendors such as Workday or SAP. And the purposes of these are to oversee employees and payroll and leave management and aspects like that. And each of these domains ship with preloaded entities and relationships. And so what you're not doing is reconfiguring another vendor's interpretation of those domains, but you are extending your own module from it. That then also connects us then to how ontologies then serve as the core semantic model for this entire process, right? If we think of ontologies as the word, right, that can sometimes put people off, but you can also understand it in what it means in this context as a formal map of your domain. It describes what exists in your system, what they are called, how they relate to each other, what rules govern them. And you can think of them as the glossary or grammar of your business logic, written in a format that any machine can read and act on. And in many cases, it is expressed as a standard format called OWL or Turtle. And OWL stands for Web Ontology Language. And Turtle, on the other hand, is a compact, human readable way of writing out these relationships. These are not proprietary formats, but instead they are open standards that are used by knowledge graph systems and semantic tooling all over the world. And that matters because your model is not locked into any one vendor's file format. It is yours and other tools can consume from it. So for example, if you take a typical large organization that has a procurement team that uses a vendor, which has a concept called purchase order, right? Their supplier relationships are managed in a separate system that calls the same thing a vendor contract. Their finance team, for example, has a third system that refers to the same relationships as a creditor obligation. So what you end up having are three words for the same thing in three systems, and they have to be synchronized with each other. And so what the ontology approach says is that you define what is a supplier, you define what a purchase order is, and you define the relationship between them once in your model. And that definition becomes the source of truth, where every generated system refers to it. And the roles of your definition in the ontology become enforced permissions in the generated code, not a policy document, like we said, that sits in someone's email, but it's an actual rule that is embedded within the system. And you can also import existing work into the ontology. So if your organization or business or what you're building already has existing UML diagrams or an existing database, those can be brought in and therefore enriched, right? Where the ontology can also be exported and used in knowledge graph platforms or governance tools or semantic reasoning systems. And this is what makes a generated system different from a template. The system reflects your business knowledge logic and not a generic approximation of what a typical business might look like. And then from there, we can then move on to how it looks to move from a model to a system and to understand what actually gets generated from that model. And what we can see is there is at minimum 197 files in a single generation run. And I want to be specific about what those files are, because 197 can sometimes sound like a number that gets made up. But what it consists of is a React front end. And because React is the JavaScript framework that most modern web interfaces are built with, the generated front end includes the dashboard, the data entry forms, and the entity management screens, right? And then from that also you get the Node.js and TypeScript backend. And that is the API layer, the logic layer, the code that handles incoming requests, enforces business rules, it talks to the database, and it also returns data to the front end. Whereas TypeScript is a version of JavaScript with type checking added, which makes the code more reliable and easier for a team to maintain over time. And then you also get MongoDB schemas, which are a database system that define how your data is structured and stored as well. What I would like to also emphasize are the API documentations, right? Where an open specification or can be understood as an open specification as the standard format for describing what an API does and how to use it.
Christina, we have a question.
Yeah.
Igor, you're welcome to speak.
Yeah, thank you very much. I just want to clarify because I reviewed about the slides, so I'm interested. What is your opinion about Supabase about Airflow as well, as it is used now for doing some vibe coding things?
If you have any questions, guys, please feel free to drop them in the chat below and we'll answer them towards the end. Awesome. Okay, cool. And then from there as well, like I was saying, you get the full API documentation, which is the standard format for describing what your API actually does. That includes a Swagger UI, which for those that are unfamiliar, is a visual interface for exploring and testing those API endpoints. And also an MCP endpoint, which stands for Model Context Protocol, right? Which is an open standard that allows AI agents and developer tools to interact with a system in a structured, programmatic way. So when your generated system has an MCP endpoint, an AI agent can discover what the system can do, query it, and invoke operations. And because the MCP endpoint is derived from your ontology, the AI agent is reasoning from your domain definitions, and it's not guessing. And that is the practical difference between an AI that is useful and one that is confidently wrong. And this is significant, particularly if organizations are working towards agentic workflow processes where AI systems handle multi-step tasks with minimal human intervention or AI-assisted operations, right? Where the generated backend is the integration point. And because it is derived from your ontology, the AI agent working with it is working from your business semantics and not from a vendor's approximation of it. You get an authorization layer, the role definitions from your ontology become actual middleware in the generated code. Another key aspect of this is the documentation that can then serve as the evidence. And one thing that tends to surprise people when they first see a generated system is that the documentation already exists. And it's not a summary of something that someone wrote 6 months after the system went live, but instead it's generated alongside the code, right? From the same domain description before the first line of custom logic is written. And it includes an executive summary, a diagram inventory, which lists and describes every UML diagram that is generated from the system. It also includes a domain model description and a version history that tracks what changed, when, and which stage of the design process. And so you may ask, why does this matter? Well, in a traditional implementation model, documentation is always a lagging indicator. It describes what was built and not what was intended. And so the gap between the two is where misunderstandings live, where disputes between clients and vendors start, and where handovers go wrong. And you can see that the generated documentation tends to be a leading indicator because it describes the intent. A business stakeholder can read from it before the system is fully built and say, yes, this is what we asked for, or no, this is not right, and we want to adjust something before any development commits, right? So that then becomes the sign-off that can happen at the design stage and not after a significant budget has been already spent. And so for procurement teams and internal audit functions, the traceability here is particularly valuable. You can trace every decision from the description in the ecosystem code wizard through to the diagrams to the deployed API endpoints. And that audit trail is not reconstructed after the fact, but instead it is generated as part of the process. And so this changes our understanding of owning your system outright, right? To think of it as more than just an abstract principle, but to look at it from a practical sense as well. So firstly, there are no license renewals. The cost of a generated system is then front-loaded. You pay to build, and then after that, the cost of maintenance and infrastructure, which are the costs you control and can predict, are therefore embedded. And they are not an actual access fee that increases regardless of whether the software improved during the year. And for most organizations, the question that is worth asking is, what does year 5 of our current contract look like? And how does that compare to year 5 of a system we own? That comparison tends to be uncomfortable once you do the arithmetic. Secondly, there's no vendor dependency on your critical data parts. When your core business logic runs through a third-party system, you are not subject to their roadmap decisions, their pricing decisions, and their sunset decisions, right? So when they discontinue a product or feature your business depends on, owning the code means that the system evolves according to your needs or on your timeline, right? And then thirdly, the system also evolves with the business. When a domain that is generated from a system needs to change because the business has changed, you are able to update the domain model and regenerate, or you modify the code directly. There is no change request to a vendor. There's no waiting for the next product release, no discovering that the capability you need is not on their roadmap for the next 2 years, right? And fourthly, the total cost of ownership over 3 to 5 years looks fundamentally different. And this is not a speculation. If you take the license cost, the implementation cost, the ongoing consultant cost, and also the upgrade cost that most enterprise systems carry, and you compare that to the cost of building and maintaining a system you own outright, the numbers diverge meaningfully in the medium term. And so I'm not saying that enterprise platforms have no place. Some organizations genuinely need the compliance certifications, the integration ecosystem, and the global support infrastructure that many vendors provide. But for many organizations, particularly those that are within the range of 200 to 2,000 employees with specific domain needs, the platform economics have not made sense for a long time. And so the question is, what the alternative look like? And this hopefully provides a view and a perspective on that approach. And so we've covered quite a bit of ground in this sense. And I would like to open the floor for our attendees today to think about what this can look like for them, right? What enterprise software is your biggest pain point? What is a specific product or a specific license arrangement or a specific integration problem that you are facing that you would like to share with us for us to hopefully understand and provide some feedback on that? And also secondly, what would you build differently if you owned outright from your experiences on using enterprise systems, right? If tomorrow you could take the logic that is embedded in your current system and convert it to something that you own and control, what would you change about it? And then thirdly, what does good enough actually cost your organization or your role in terms of financial terms or even just productivity per year, right? Not just the license fees or the consultants or the time or the workarounds or the staff time that is needed to manage a system that doesn't quite fit, but also the opportunity cost of being locked into everyone else's roadmap. And so the point here is to understand what the landscape that we are in is looking like at the moment and what that can be transformed into using AI capabilities that are built for this particular purpose. It is not a generic system that just builds whatever, but is particularly aligned to the industry standard of systems that operate at scale and require an intelligence that works, right, that has a continuity from the beginning of the design stage, but also from the implementation and output of it as well. And so if you would like to explore everything that we have discussed here today, we have everything available on ecosystemcode.com. There's also an option to set up a session with us, the product team. We are more than happy to work alongside you for specific use cases and understanding how the platform can be integrated into your work to get the best possible output and to provide a more personalized and customizable walkthrough of everything that we have discussed here today. Okay, cool. Igor, you mentioned something about Supabase. Do you mind just repeating that question for me before I jump in so I can target everything for you?
Yeah, sure. So my question is, how good is to be used base as a DB, because you mentioned only another one, to be used kind of a server, because it's, still we are doing some client server applications. And from time to time, it is a good option for vibe coding. So what is your opinion on this? Is it still alive or it not make sense? Thank you.
Mm-hmm. Okay, awesome. Yeah, I genuinely do think that Supabase is a good tool. In this case, we do mainly focus on generating MongoDB by default because it fits the document-oriented shape of most of the generated entities out the box. And so Supabase is a solid alternative that is worth knowing about. But I think for teams that are more comfortable with more relational databases and that need that strict schema enforcement across the complex joins, then Supabase is also a legitimate choice. And also to think about the fact that the database is a configuration decision downstream of the domain model. So the ontology does not care whether your persistence layer is in MongoDB or PostgreSQL. But what matters is that the domain is modeled correctly first. And so once that is a solid layer, swapping the database then becomes a tractable engineering problem. And so the point is to provide that customization from the get-go that you then can configure. And our provisions for different options on the platform also are particularly a use case. So yeah, I would be more than happy to provide you with a walkthrough and to understand what you are building as well.